I love integrations. And the thing that I love the most about integrations is that a lot of developers don't know how to configure them properly, which can lead to a lot of nice high impact vulnerabilities, which don't require any really crazy chains or, crazy patterns to exploit. We can show high impact pretty easily with access to customer data. And today I'm going to talk about some of the integrations that have been misconfigured by applications and that have been documented by other bug bounty hunters and researchers either through disclosed reports or write-ups on platforms like Medium or whatever. And I want to focus on three core integrations today, one of which is Stripe, which is a very commonly used payment integration for platforms. It's how they process basically whether or not you've actually paid for a product or not, how much you've paid for, and what you've actually paid for. The second integration is Zendesk, which is a commonly used help kind of support ticket type system, which is used by companies to handle customer support. And the third is Intercom, which is something quite similar to Zendesk, where it's kind of like a customer support thing, but it works in a bit of a different way where it's integrated more directly onto the website, where Zendesk is kind of a more back-end system. So I want to talk about these integrations, and I'm going to basically break down the root cause of the issue and how you can kind of find more similar patterns of misconfigurations on different services just by kind of understanding how they work and how the website is actually trusting the service in a number of different ways. So let's get into it. So the first integration that we're looking at is going to be Stripe, and in particular Stripe webhooks. So Stripe actually has a bug bounty program, and I've hacked on it before. I've had a little bit of success with it in the past, and I know for a fact that Stripe is quite complicated. It's quite a complicated system, but I do know a decent bit about it just because I have hacked a little bit on the bug bounty program, but I haven't looked for misconfigurations in this integration. But I have seen a lot of companies using this. I have like almost every really big public bug bounty program is going to be using Stripe to process billing and stuff. And some bug bounty programs have different attitudes to how billing, bypasses should be awarded. I have seen it awarded as from anywhere from informational to high, but it just depends on the company, and you need to know whether or not the company cares about that. But either way, these billing bypasses are kind of fun to find anyway. If the company doesn't care, then maybe just use it yourself or whatever. But either way, the way Stripe kind of works is that, you integrate this SDK on your backend, have the customer kind of pay through Stripe, and then you have to kind of query Stripe to figure out whether or not the user actually paid or not. And in a lot of cases, this doesn't require using webhooks, but in some cases it does, particularly for subscriptions. So the way their webhooks work is whenever some kind of user event happens, Stripe will send you a JSON request to an endpoint that you kind of specify on the backend dashboard and stuff. Well, by nature, this endpoint has to be public. So it has to be publicly reachable so that Stripe servers can actually send this webhook to you, right? So this needs to be publicly reachable. And it can't be behind any firewalls, so it has to be publicly discoverable. So that means that you can always reach this endpoint yourself. So as an attacker, if you know the name of this endpoint, you will be able to reach it because it has to be public for Stripe to use it. And the second thing is that it has this kind of signature verification system, but it is optional. So that's the kind of thing that we need to see here, is that the signature verification of Stripe is not compulsory. So although the SDK does hint you towards this, and they have kind of made improvements to this, it's still not enforced completely. You can't choose to ignore it. And there is also different attacks that I'm going to talk about in a minute. But the kind of common misconfiguration that this researcher here, Jack Cable, was talking about, and this is quite an old report, but I have seen this showing up in more common vulnerability disclosure reports. But either way, what he kind of found was that, he was looking at some kind of API documentation. He found this API/webhook/Stripe endpoint, and when he sent a JSON request that was commonly sent by Stripe, he was able to basically bypass the payment completely. So the server thought that Stripe actually sent them like a payment request that like the user had successfully paid, which is presumably what the server was listening for in this webhook. And you would get this kind of ID parameter back, and it would say that it is successful. So this is not an vulnerability in Stripe, right? So let's get this clear, right? This is not a vulnerability in Stripe. This is a vulnerability in the party that implemented Stripe because they didn't verify whether or not the webhook was coming from the right person. Now, one of those things that you can do is you can actually whitelist APIs, so it only allows Stripe servers. And this sounds like a good idea. This sounds like a really good defense. But what you can actually just do is you can actually create your own Stripe account, and you can actually link your webhook to the exact same webhook as the company is using, and then send your own webhooks that way. And this will match the IP because it is also being sent by Stripe. So IP whitelist is not a valid defense for this. The only valid defense is to use the secret key to actually validate whether or not the Stripe signature is there and whether or not the signature is signed by Stripe itself. And back in the day, they used to have this bit of code here, and it literally basically was vulnerable, which is pretty funny. It was vulnerable to this kind of attack. Now it's not. The documentation is very significantly changed, and it has significantly pushed security, but this could potentially still be an issue. And it could still be an issue in other payment providers. So if you look here, the kind of researcher here talks about different, payment providers. And, in terms of Braintree, which is like a different provider I never heard of, apparently in order to use their SDK, you literally have to use this. So you have to have signature verification enabled, or else you can't use it. In Stripe, I believe that this is actually not the case. Maybe they've changed it recently, but I'm pretty sure signature verification is not mandatory, so you can choose to not do it. And in some other payment providers, I imagine this is also an issue. In general, webhooks, a lot of companies use webhooks actually, so it could be worth looking into that way. And then one of the funny things is, BitPay, a service that accepts Bitcoin payments, says BitPay does not sign IPNs, so the information in the payload should not be trusted. So basically, they're saying, yeah, don't trust us, basically, which I think is pretty funny. They just say that, but that's interesting there. Well, yeah, it's, as the research says, it's common in subscriptions because the service is listening for this subscription renewal webhook from Stripe, right? So whenever your subscription is renewed, they listen for this webhook and then they auto update it on the system. So that's why these type of vulnerabilities are common on subscription platforms, which, let's be real, nowadays, that's pretty much all of them. That's why they're common on there. And it just talks about different endpoints that it could be. You're looking for GitHub, or JavaScript files actually as well, which is a big one. Use like JXCloud or something, download JavaScript files and see if they have any Stripe endpoints there. But yeah, that's kind of the misconfiguration there for Stripe. There are a lot of other ones for Stripe. This is kind of just to give you an idea. But I wanted to look at this report as a kind of way to look at these webhooks, because a lot more services than just Stripe use webhooks, right? Even more than just payment providers, like Slack or whatever uses webhooks as well. A good kind of channel to kind of forge requests from a trusted service where the app is placing trust on the service, and we as the attacker can kind of exploit that to basically make the app think that it's coming from the legitimate service when it's actually not. So I think this is a great vulnerability, and these webhooks are something that should be looked at, especially whenever you're hacking on a bug bounty program. You see they have webhooks, well, maybe other companies are implementing these webhooks and they also could be vulnerable. That's a good idea there. Another kind of Stripe vulnerability, this is outside of the scope of this report, but the private API key is getting leaked. Sometimes that happens. So on Stripe, there's a publishable API key and a private API key, and the publishable API key has to be put in the JavaScript, but the private API key can't be put in the JavaScript. And in some reports, they found that the private API key was also in the JavaScript. So, just a classic API key search, but anything happened there. And yeah, that was the vulnerability in Stripe. So looking at the webhooks. So now we're going to move on to Zendesk. And this is the report in Zendesk. I actually really enjoyed reading this report. I think it was very engaging by this researcher Init de Coclea. Okay, I definitely didn't pronounce that right. I apologies. Anyway, all the reports are going to be in the description, so you can have a read of themselves. But he talks about using these help desk platforms like Zendesk to try and basically spoof email addresses that have a legitimate company name that basically allows him to register on platforms like Slack. So let me explain that a bit more briefly. Right? So, Slack is like this messaging platform. It's a bit like Discord, but more professional. And basically on Slack, there's this kind of weird thing where you register your workspace with an email address. Instead of creating an account or whatever, you register with your email address. Your access token gets sent to this email address, And then there's not really any password. So I think Slack is more or less kind of passwordless. You instead sign in with your email. And then what you can do is you can access any workspace that is kind of tied to your email address. So let's say you have an email address like @example.com, right? If you have this email address and you create a workspace, and anyone with the same email address, so @example.com, will be able to join your Slack workspace automatically. It's kind of set up this way because most companies, they basically have these custom email domains and they want their staff to be able to join automatically. They don't want to have like bureaucracy there. So Slack is kind of helpful in that. And I'm pretty sure this is the default setting on Slack. So it's really good when it's default, because that means that the mistake is going to happen more often than not. And what this kind of hacker was looking at was finding ways to impersonate this @example.com email address, trying to find ways where you could basically receive emails from this email address without actually owning it in some way, by, you know, the company giving you access to it by some feature, or, you know, by accident. And one of the really cool reports that I saw this hacker talk about was on GitLab. On GitLab, you could basically, what you could do is you could have an email address to create an issue for GitLab. And this was directly on the GitLab email address. So there wasn't any, different domain. It was actually gitlab.com. And what the researcher basically thought about was, what if we could set this as our email address for Slack? And when they did that, they saw that indeed, because they were able to access this email address through GitLab, they were able to get on the GitLab Slack, and then they were able to see all the internal message channels that were visible on the Slack, which is a very big, privacy leak for this company, because it probably contains, stuff talked about by the internal dev team. Maybe there's, a lot of information disclosure there. So it is a pretty serious vulnerability, and I thought that was very cool, because I was just thinking like, wow, that's like something that I wouldn't even think of when I set up this. Like, if I was coding this feature, I probably would never even think that that's a realistic scenario that can happen, that someone can use this to sign onto the Slack. I think that's very cool. But yeah, anyway, that was kind of a nice thing. And the second one is a tiny bit more complicated, but I'm going to explain it now. Basically, what can kind of happen on some of these platforms is, imagine you have like this, company, whatever, example.com, right? And they're integrating with Zendesk. What basically happens is, when you create an account on example.com, you create it with an email address, and you have an account there. Okay, cool. And then they have a support@example.com email address. What sometimes happens with these kind of services is, if you email support@example.com, then what will happen is, inside your account, it will automatically create a support ticket for you with the contents of that email, and it will be linked to whatever account actually sent the email address. So if we send an email address, let's say I'm, hacking on this, and I create a new account, and I set it up with the email address test@yaksec.com. Then I go off and I email support@example.com with test@yaksec.com. What will happen is, when I log into the platform again, that email will be visible from the platform, and it will basically show me the contents of the email, and they'll create like a support ticket on these platforms like Zendesk, Kaiko, or other help desk tools. So it'll be visible from their basically panel, like their support panel. And what you can actually do, I think this is like some 200 IQ thing, where if a service doesn't have email verification turned on, if you create a link like feedback@slack.com, which is where Slack sends their like verification links to. So Slack will send their verification links, or they used to send their verification links from this email address, feedback@slack.com. If you register an account with that name, and then you go to their Slack, and then you try and sign up with support@example.com, then what will happen is, feedback@slack.com will send, the actual Slack platform will send the magic token, or like the sign up link, to support@example.com. And then support@example.com will see that, and it will see that feedback@slack.com is a registered user on the website, and it will create a support ticket on Zendesk for that user with the contents of the email. And in the contents of the email is going to be the verification link from Slack. So you will be able to sign up, which I think that is some highly big brain move. That is like crazy. I don't think I would ever think of that. And it's just the kind of third party integration where someone who really doesn't know the platform, or like the developer who doesn't even know about the service, is never going to think about. So this is a great type of vulnerability because the developer has to have this kind of explicit knowledge to prevent the vulnerability, which in this case they didn't. So it was like everything was working fine, but the combination of chaining these things actually caused the vulnerability. Neither of these things by themselves were a vulnerability. So I think that's very cool. And yeah, they basically talked about this, thing here, and they were able to join their Slack as well. And the same thing with Yammer or whatever, these other basically, these internal messaging apps, or any app that basically allowed signing up with an email address, or they were even able to like reset the password for an account linked to like a support email address. So that was pretty cool. And they basically got a decent bit of money from this. So they were getting like 8K for, some of these bounties. So that's pretty good. It's probably like a very high there. One on GitLab, which I don't know how much this was. Let me see. Maybe we'll have a little look at this if it's public. Let's see. It was marked as critical apparently, so it must have been a decent bit. Not sure what the bounty is, but let's see. Anyway, basically the researcher talked about this in Slack, and they basically asked them to change this feedback@slack.com email address to something that could not be guessed by an attacker. So in case of these support services being used, he said that this should be randomized so the attacker cannot predict what email address Slack is going to be used. And they actually implemented that, and they also rewarded them 1.5K for it. So I think that was very cool. That was kind of the vulnerability there, leveraging these systems set up by these companies, these help desks, and internal systems like the GitLab issue tracker to pirate these email addresses that were used by the company in order to self-register for platforms that they weren't supposed to be able to self-register for and access internal messaging or reset passwords on certain services. And that was really cool. So I hope you enjoyed that vulnerability as well as much as I did, and go give this one a read yourself because it is very nice. Now we'll move on to the next one, which is in Intercom, which is kind of similar. It's like a support platform, but the vulnerability is a lot simpler than this, to be honest. So Intercom is like a support platform like Zendesk, stuff like that. And the way it usually works is the following. So we have usually like an iframe, which is embedded in the main website, which is like a Intercom iframe. It's like iframe messaging.intercom.com or something like this. And the main website communicates with that iframe using post message, and then the iframe will send requests to the backend API for Intercom, which is like widget api.intercom.com or something. And all of the authorization will be done there. So the point is that it uses post messages and stuff to communicate. And this vulnerability is very simple because it's just basically one setting on Intercom. In like the Intercom console, there's an option to set identity verification to true or false. And if you set it to false, then you can become any user. So that's basically it. Basically, what will happen is this website will kind of boot up Intercom. It will register the SDK for Intercom on itself, and it'll set up everything as the user. But if this secure like login is turned off, then you can basically register yourself as any user, and Intercom will automatically go fetch the previous conversations and load them in your browser in this iframe. So that was the vulnerability basically. And what you could do is you could just run Intercom. You could actually use the SDK from your JavaScript files. You could run Intercom boot, and you could boot as whatever email address you wanted to, and that would give you access to the conversations. Now the impact of this is pretty nice because you can view someone's support conversations. These conversations could be very technical, and they could be in depth depending on what the platform is. Maybe someone's like asking like why my API key is not working, and they put the API key into it. So you never know when there's a GDPR breach. So it is pretty good impact. It's probably like a high on most platforms for something kind of stupid. But yeah, the proper way to implement this is basically to add in secure verifications to take that box on Intercom. And then what has to happen is that the main like server, which has the signing token, will sign a user hash, so with your email, and it will pass it down to Intercom to this post message, or otherwise Intercom will not accept the request. So if you try to send it yourself, it won't work because it'll say you don't have this like secure hash that you need to fetch using your secret, which is only accessible to the backend server of the website. So that's basically the whole vulnerability. And there's a few other things you can do if this is disabled. You can like update, like you can like send messages on other support tickets. You can, do a whole lot of different things. So it is a pretty nice vulnerability, but it's very simple. It's just a thing on the Intercom dashboard. So nothing as complicated as the Zendesk one this time, but still kind of cool and maybe worth running. I think someone made a tool around this as well. So if you see Intercom, maybe just run this and maybe you'll just get like free 5k or whatever in your bank account. I hope you enjoyed this video talking about some third-party misconfigurations in different services. I really do enjoy hacking on these third-party misconfigurations because really it's like the developers aren't going to know a lot of these things. They're not going to know how these third parties work on the back end, and they're not going to know every setting. They're not going to read every documentation. So it is easy to miss things, especially when they're taking a bit of shortcuts and trying to, assume that it's something secure because it's kind of not really like public, like the Stripe webhook. A lot of people probably aren't going to find out about it, so it's secure. But if someone like enumerates it, then it's not really secure anymore, is it? So it is nice to hack on them. I really particularly enjoy misconfigurations where the actual misconfiguration is enabled by default. So this is kind of what you want to look for if you ever want to do research on misconfigurations. Then try to find something where it's misconfigured by default. For example, on that Zendesk one, it was the Slack backdoor was open by default. So if you were able to get that email address by default, you were able to log into the Slack. So that's really good. And then the second part was just trying to find where the developers are making that mistake. And if you put the Zendesk thing together, which by default will, assign your email address to the actual user. So if you send, the support email, and it will automatically create it for user. If you put 2 and 2 together, you'll see that a lot of companies will be vulnerable to this. So these kind of default configurations are very good for kind of just printing money, honestly, and finding a lot of common misconfigurations across a number of different services, which is ultimately what we want, because we don't want to get just one bounty when we could actually reproduce that bounty numerous times and actually get a very nice payout in general. So yeah, I hope you enjoyed this video, and yeah, that's it from me. Thanks for watching and happy hunting.